Okay, so the first thing that we're learning is exponents and radicals, and the first part of that is number systems. It's a pretty quick lesson. You guys will get your assignment afterwards. It'll come right off of this notebook. So the first things. Every number that we deal with is called a real number. There are things that aren't real numbers. Everything we deal with is real. An example of a non-real number would be if you tried to do like the square root of -1. It wouldn't give you anything. Your calculator would just say error. So everything is under the blanket umbrella of real numbers. And we have different subgroups that you see throughout, and I can't touch the same with the fingers or else it does things. Well played. Natural numbers. Natural numbers. These are your counting numbers, is what it's referred to as. So it's like 1, 2, 3, pretty simple. We represent natural numbers with the letter N. I lost my little sidebar, so I can't change it to draw on it. But it's this letter N right here. Whole numbers is just all your natural numbers plus a 0. So it's your counting numbers and the number 0. Integrals. That's all your natural numbers, all your whole numbers, plus all your negative numbers. So it's your negative counting numbers added on. So -1, -2, -3, -4, -5, and so on. -1,000,000. Not decimal places. Those are represented with I's. The letter I. Rational numbers. This is when things start to get confusing. Q is the representation for a rational number. These are numbers that can be written as a fraction. So it includes everything we've already talked about. So what's the fraction for -3? Just be -3/1. Right? So your rational numbers that we see down here can all be written as fraction. To tell if they're written as a fraction, it means the decimal repeats. So on your sheet, you should see decimal 33333. Right? See that pattern there? We know that's going to be decimal 333 forever. So that could be rewritten as a fraction. That's actually just 3 1/3, right? You also see some other examples. -1.5, -0.5, 0, the square root of 0.16. Would that be a rational number? Punch in your calculator and see what the square root of 0.16 comes out to be. Remember, you have to at some point upgrade to one of these big calculators. One of these crappy ones right here. At some point, you'll need that. Stop your parents. Square root of 0.16. Who's got the answer? 0.4. Can 0.4 be written as a fraction? You can. So 4/10 would be the fraction. If you get one of those graphing calculators, I'll show you guys how you can just check if things are fractions right on your calculator. Now, the tricky one, irrational numbers. That's a Q with a little line over it. If I could draw on the board, I'd show you, so I'll do it on the side whiteboard here. It's just a Q with a line over the top of it. That means irrational numbers. Irrational numbers are all real numbers that are not one of these. It can't be represented as a fraction. It cannot be represented as a fraction. It does not have a repeating decimal. So it doesn't go 0.464646 forever. Yeah. So, would 1.6789, all that madness, there's no repetition, right? That's an irrational number. Pi is 3.14 and it just goes on forever. All these numbers go forever. You'd never find the end of it. They never terminate, they never repeat. Any questions? And what are all of these things called? They're real numbers. Okay, flip it over. This is a Venn diagram. This is supposed to represent the number system we just talked about. So what would be the absolute smallest circle?
Natural.
Natural numbers. What are our natural numbers? Somebody else. 1, 2, 3, 4. Counting numbers all the way up. Correct. So that would be the smallest circle. So you can fill that in. With your group, talk it out and try to fill in the remaining circles. There's a spot for all the groups. And don't forget real numbers. Real numbers are the letter R.
So whole numbers.
I did this.
So on the inside, we had natural numbers. That's our N. Thank you. What would be the next biggest thing that includes all natural numbers? Whole numbers. And it's just, what's the extra number it adds?
0.
0. What's the next greatest one? Integers. What do those include? That includes your negative counting numbers and whole numbers. What's going to be the next biggest one?
Rational.
Rational. How do we represent that? Just a Q. Yeah. Where are we going to put irrational numbers? On the box and down the side, right? That's pretty simple. Why is it on a box on its own? Because it doesn't include any of these. And then where's real numbers go?
Like on the outside of the entire box.
Yeah, so I'm going to put it up here. Somehow. No, I'm not. We're going to put it up there. Those are your real numbers. It includes everything in this side of the box and everything in this side of the box. So what you're going to have to be able to do is when I give you a number, you're going to have to be able to tell me what it belongs to from smallest to largest or from largest to smallest. So the absolute smallest group would be your natural. But if it's also a whole, then you're going to include that. And so on and so forth to be smallest to largest. The biggest one is always real. The smallest one is natural. Okay, let's do an example. For the following, write all all the sets of numbers to which the given number belongs. Write the answer from the largest set to the smallest set. So we'll do number 9 together. What's the largest thing it belongs to?
Whole.
Real. Real is the largest. What's the next thing it belongs to? Rational? How do we represent rational? Q. Right there, guys, is going to be a common mistake because you're going to want to go with the first letter. And you're going to think rational and you're going to put R. R is for real. The Q is for rational. Make sure you highlight that somewhere on your notes so you don't forget. That's a common error. What's the next thing it belongs to? Integer. And then whole. And then natural. Largest to smallest. If you look at your chart, you'll see how we focus in. We'll do B together, and then I'll let you guys go on your own for the next one. The square root of 5. The only way we're going to know that is if we punch in our calculator and see what the square root of 5 looks like. Punch it in. See what you get. 2.236067977. Everybody else get that did it? 78? It just rounded up differently at the end. Okay. Is that a real number? It's a real number. Now you ask yourself, is it a rational number? Is it a rational number? No. Why is it not a rational number? Because it goes past the calculator screen, so that's your first check. The second thing is there anything that's repeating? No. So it never terminates and it never repeats. So then what must it be? Irrational, which is Q with the line over it. Partner up within your teams to go to the remaining 4. If you guys have a question, put your hand up. I'm going to ask people to go up on the board and answer it. Work together, guys.
I'm just trying to see everything square root with the practice. Drop it off as you know,
if you can't punch in this next one on your calculator, you guys have the E. Look at E. You're going to need someone with a calculator that knows how to work that. Tell me what it is. So find a partner. Start on the outside, now your way down. Is it a real number? Yes. Is it rational or irrational? That's going to be a question you have to answer.
So E is all of them. So it's real.
See if you can find someone who already knows how. Yep. You will need it. You'll always need a calculator, but you don't need it. Take a guess, then we'll talk about it.
This one also does.
Does everybody have someone that they're working with that can figure out E?
I don't know how to calculate.
For example. For now, Dawson will help you out. And you guys will do the same thing. We work together as a group of three. We're also going to let half the class go get calculators.
What? Oh, this is actually negative 3.
You guys need to come prepared to class. You need calculators every day. You need pencils every day.
Okay.
So far, start biggest to learn. As long as you can try your best to justify why it is what it is. As long as you think you can justify it. Okay, let's do this as a group, guys. There's a few tricky ones, right? Okay. Ladies and gentlemen, let's start with C. 7 divided by 11. Is it real? Yeah. They're shaking the floor up. It's real. When you punch 7 over 11, that's obviously a fraction, right? So, can it be rational or irrational? It's rational. Because it can be written as a fraction. It's already in fraction form for you. What's the next? Boys. What's the next one? What's the next smallest group? This is what you have to ask yourself when you do these questions. Look at your chart. Integer. What's an integer? It's positive or negative counting numbers. That's not a counting number. So it's not an integer. Now the beauty of doing it this way is once you figure out what it isn't, you can stop. If it's not an integer, there's no way it's a whole number and there's no way it's a natural number. So let's do it for the next one. -7. Is it real? Yes. Never forget to ask if it's real. That should always be the first letter on these answers. When you're doing largest to smallest. Is it rational? Yeah, it could be a fraction. 7 by itself, just -7 over 1. That's a fraction. It terminates. There's no decimals after it. Next one, what is it? What's the next biggest thing? Integer. Integer is the next biggest one. Integers are positive and negative counting numbers. Is -7 a positive or negative counting number? Absolutely. Next smallest. Whole. What are whole numbers? Whole numbers are your counting numbers plus 0. Not negative. So we're done. As soon as you find out where you're done, you're done. This next one's the hardest one, probably. There's a couple below that are a little trickier, but this one you guys are struggling with your calculators, right? You all need a scientific calculator that looks like this. They come in a lot of different variations. Joe's looks like this, but it needs to say TI-83 or TI-84 on it. They cost about $100. You need to go home and talk to your parents and find out where it is, if you have one already. If you don't have one already, you need to go buy one at some point. I could cheat you. You can get them for way cheaper. Once people graduate, they just sell them for way cheaper. When you punch this properly into your calculator, what would it come out to say?
3.
It's equal to -3. That's the negative cube root of 27. What's the first question we have to ask? Is it real? Yeah, it's real. Next question. Is it rational or irrational, right? That's the next one. Rational. Next question. Yeah, the color comes and goes. It's having some troubles with the light bulb. It is an integer. Why is it an integer? It's a negative counting number. Is it whole? No, wholes are 0 and not counting. The next one. 2.346346. You might also see this written as 2.346 with a line over it. Just like that. And the line would only go over the first 3 digits. So if you ever see that, a line over top of numbers, it means it's those numbers repeated forever. So if I gave you guys 3.32 and the line was over just the 2, that means the 2 repeats forever. If it's 3.32 and the line's over the 3 and the 2 like that, it means it repeats 32, 32, 32, 32 forever. Question? That's a great question. Is it rational or not? So, this one is 346, 346 forever, so the line would be over the 346. Is it real? Yes. There's our R. And then the question is it rational or not? The 3 first? Yep. This would be rational, this would be rational, and this is also rational. It doesn't matter what's repeating. It doesn't matter if it's 100 digits that all keep repeating, or if it's 1 digit that keeps repeating. If it's repeating, it's rational. This repeats 346, 346, 346. Yep.
So you're saying it's 3.32.
Yep. It's rational because the 2 repeats forever. As long as something repeats forever. So this is rational. Up here, this would also be rational. This would also be rational. Is it an integer? Question.
How large can the pattern be before it's no longer considered a pattern?
The patterns that you guys will see probably won't get bigger than 3 digits. But technically, it doesn't matter how big it is. So if they could find a pattern that's, say, it repeats every 100 digits, then that would still count. I mean, we don't ever work with anything like that, but if it was there, it counts. Is it an integer? No. So we're done. Hold on. This one down here was tricky. 1.11223344 because there's a pattern. But is there a repeating pattern? No. To be rational, it has to have a repeating pattern. So if we saw it go 1122, 1122, 1122, that would count. But we don't know what happens after 77. We probably can assume it goes 88, then 99, but then we don't really know. It hasn't ever repeated itself. It's just a pattern. So, is it real? Yeah.
If you look farther down the pattern, like 88991122.
Yeah. Then it would be. So if he asked the question if it went 8899 and then started over again, 112233, that would be repeating. So that would count. If it's not rational, what is it? Right. And finally, H. Is it real?
Yes.
Yep. What's the next question?
Irrational.
Is it rational or irrational? Why is it rational?
Because it ends.
Because it terminates, correct. seems simple, right? And then you get examples like this, and it's not so simple anymore. So, here's a tip for those of you with graphing calculators, which is why those of you who don't have graphing calculators are going to want to find a graphing calculator as soon as you can. This is how you can figure out if something can be written in a fraction or not. So if you look on your paper, it's covered up on the board right now, but if you look on your paper, it says, type your decimal number. If it repeats, make it obvious, which means just type it a lot of times. So 3.3333333. Don't just stop at 1.3. Yeah? Yeah, do a bunch. Just make it very clear to the calculator that you're trying to repeat. The next thing, there should be a math button down the left-hand side. Yep, right there. It's the third button down. It should be under alpha. Click that. Then you'll see a fraction button. If you click the fraction button and hit enter, it'll write out whatever number you had before as a fraction. If it can be written as a fraction, it's rational. If it can't be written as a fraction, it's irrational. So if you have one of those calculators, it becomes really easy to figure out that first question. Go ahead and try it with those bottom questions right there. Try to answer those as a group. Largest set to the smallest set. Your guys' brain is really small on your thing, right? It's the same as up here on the board. So the first one's -2, then the square root of 36, then 3.14159,265. I think it's supposed to say ... It doesn't. It would be pi, is what they're trying to say. So it should be a ... there. Just do ... Just to make it a little funner. No, let's not do ... I don't know how to do that anymore. Are they all real? Let's see what I got. Are they all real? No? Which one's not real? Yes, they're all real. Are they all rational? Since this one doesn't have a ... they're all rational. If it did have a ... then it would be irrational. Yeah. That's why I confused because I said the other way. Which one of them are integers? A is an integer and B is an integer. C and D aren't, so they can stop at rational. Are A or B whole numbers? What's a whole number? What is a whole number? What's the definition of it?
Counting numbers, negative or positive.
Those are integers.
Counting numbers.
Counting numbers plus 0 are whole. So yep. This one, B. The square root of 36 is just 6. Turn around. Hey. B would be a whole number, and would it be a natural number? Correct. Question? If it kept going ... it would be irrational. Yeah. So it would be real and irrational. Your example doesn't have the dots, which is just a mistake on my part. But other than that, it's good. That's the first lesson in number systems. We're going to need that for basically the rest of this entire unit. So what I'm going to do now is give you guys an assignment.